So hello everyone, let us solve another LeetCode question and the problem name is Valid Anagram. So let us read the problem statement first. So you are given two strings S and T and you need to return true if T is anagram of S, and if T is not the anagram of S you need to return false. So first of all, let us understand what is anagram. So let us take this first example and try to understand what is anagram. So if T is given and S is given, first of all we need to check if T is anagram or not. But what is anagram? So anagram is nothing but you just need to check if string S contains some amount of characters and with whatever frequency, then T should also contain the same amount of characters with same number of frequency. For example, let us say that string S has A coming 3 number of times, N coming as 1 number of time, then it is G, R and M. G, R and M. These are also coming 1 number of time. So for T to be anagram of S, T should also contain A, T should also contain N, T should also contain G, T should also contain R and T should also contain M. And not only this, the amount of characters should also be same. For example, A is coming 3 times, so T should also contain A 3 times. If N is coming 1 time, T should also contain N 1 number of time, not more than that and not less than that. If G is coming 1 number of time, T should also contain G 1 number of time. If R is coming 1 number of time, then T should also contain R 1 number of time. Same for M. So we can say T is anagram of S if it follows the condition of anagram that we have just discussed right now. Now the question is how we will find if T is anagram or not. So what we can do, as we have seen just now, we are just concerned about the number of characters. We are not concerned about the position of the characters. No, we are just cared about the number of characters. So we need to have some kind of mapping in string S and string T. So what we can do is we can create two hash maps, one for string S and one for string T, and then we can just keep on checking if each and every character is present same number of time in T or not. So let me just show you. So let's say I create hash map as mp1 and mp2. So this is for string S and this is for string T. So this will contain the character and frequency, let's say. So I'm just creating roughly right now. So we will iterate on string S one by one. So first A is there, so we will insert A in place of inside the map and we will count its frequency to be 1. Then we will come across N, then we will again push N into our map and increase its frequency by 1. Then again we got A, so we will update its frequency by 2. Then we got G, so we will put G with frequency 1. Then we got R, so we will put R with frequency 1. Then we again got A, then we will update its frequency by 3. So A is now coming 3 number of time. Then we come across M, so we will put M with frequency 1. Now what we need to do, we need to do same for string T inside map 2. So let's say we are again iterating. So first is N, so I am drawing this for map 2. So N is now coming 1 number of time. Then we come across A is coming 1 number of time. Then we come across G is coming 1 number of time. Then we come across A, so A is coming twice, so we will update its frequency from 1 to 2. Then we come across R, so R is coming one number of time. Then we again come to A, so we will update its frequency from 2 to 3. So we will write here as 3. Then we will come across M and we will put M equal to 1. So this is for string T and this is for string S. So what we need to do right now is just check if each character is present same number of time in string T or not, or we can say in map 2 or not. So let me just clearly draw this again and then I will show you what I am saying. So I have redrawn both the maps. So this map was for string S and this map was for string T. Now what we need to do, we just need to check if each and every element present in map 1 has the same amount of frequency in map 2 or not. So let us check one by one. So first we will come across A. So we will check if A is present inside map 2 as well as its frequency is 3 or not. So let us check. So we got A and its frequency is 3. So we can say yes, A has same amount of frequency in both the maps. Then we will come across N. So is there any N present? Yes, N is present and its frequency is also 1. So we can say that yes, N is also present and its frequency is also same. Then we will come across G. So G is present one number of time in string S. So we need to check if in string T also it is present one number of time. So we come across G and yes, it is present one number of time. So we can say yes, G is also at its correct frequency inside map 2. Then we will come across R and R is present one number of time. So we will check again inside map 2. So yes, R is again present one number of time. So we can say yes, R is also at with correct amount of characters inside map 2. Then we will come across M. So M is present one number of time. So we will again check inside map 2. If M is present with same frequency, yes, M is also present with same frequency. So we can say yes, M is also present with correct frequency inside map 2. And then we come across end of the map. Since we didn't get any element inside map 1 that is not present with correct frequency inside map 2, so we can say that yes, T is anagram of S. So we can return true from here. So we can say that yes, T is anagram of S. And if you look at the output here, so output is also giving true. So this was the first example. So let us try this same thing on example number 2 and let's see if we get the correct answer or not. So this is the second example. String S is given as rat and string T is given as car. So again let us create two maps, map 1 and map 2. So first of all R is there, so we will push R with frequency 1. Then we will come across A. So A with frequency 1, then we will come across T with frequency 1. Then for string T, C with frequency 1, A with frequency 1, R with frequency 1. So we have created the maps for both these strings. Now we just need to check if the characters are present in both the maps with same amount of frequency or not. So let us check one by one. So first we will come across R. So is R present one number of time in map 2 or not? Yes, R is present one number of time in map 2. So yes, we can say yes, R is correct. Then we will come across A. So we need to check if A is present one number of time in map 2 or not. So yes, A is present with one number of time in map 2. So we can say yes, A is also with correct frequency present in map 2. Then we will come across T. So we need to check if T is present with one amount of frequency in map 2 or not. So A is there, R is there, C is there, but T is not there. So we need to stop here. Since anagram says that each and every character should be present with same amount of frequency, then only it is said to be anagram. Since T is not present in map 2, we can say it is not an anagram, and we need to stop here right now. And since it is not an anagram, we should return false. And if you see the output is also false. So this is how we will solve this problem. So let us see the code right now. So this is the code that I have written. So let us see each and every step of this code. It is the same thing that I have explained so far. So let us see right now. So first of all, we are giving one condition if both the strings are of same size or not. So it is obvious if string S contains, let's say, 6 characters and string T contains 4 characters, then by no means we can say that string T is anagram of string S. Since the number of characters are not same, so there is no point in checking. So we can just return false from here itself. Then we have created two maps, mp1 and mp2. This is for string S and this is for string T. So this is how we are just storing the frequency inside the map1. So we are just iterating over the string S and just incrementing the frequency of each and every character. Same for string 2. We are just iterating over string T and just incrementing each character's frequency inside mp2. So now we are comparing both the maps. So let us take one random example for clear explanation. So let us say we are taking mp1 and mp2. So here it is, let's say, a equal to 2, b equal to 3, and let's say here equal to b equal to 3 and a equal to 2. So what our code is doing is it is comparing both the frequency. It is comparing both maps frequency of a particular character. So mp1 of it.first. So what is it.first? So our current iterator would be pointing to both of these things. So this is what our it would be pointing. To get the character, we will write it.first. This will point to this character. So mp1 of it.first is what? mp1 of it.first. it.first is a. So mp1 of a. So what is this? This is the frequency value. So mp1 of a is pointing to its frequency value. So its frequency value is 2. So if mp1 of it.first, that is 2, is not equal to mp2, now we are comparing the same frequency with mp2. So again we will take it.first. What is it.first? it.first is a. So a. But in map 2. So mp2 of a. mp2 of a. So it is what? It is 2. So if 2 not equal to 2? No. 2 is equal to 2. So this will not be followed. So what we are doing? We are comparing a character's frequency in both the maps. So at any point if we are getting this condition to be false, let's say here its frequency is 3 and here its frequency is 2. So it is not equal to, these both things are not equal. So at that moment we can say this is not an anagram. So we can return false from here itself. Otherwise, after complete iteration of both the maps, we can say yes, there is no character whose frequency is not same in both these maps. So at that time we can say yes, the string T is anagram of string S. So it is the same thing that we have seen in the drawing explanation. So hope you understood this code part also. So let us now discuss about the time and space complexity. So time complexity will be O of S plus O of T. So this S is length of string S and this T is length of string T. Since we are iterating on both these strings, so its time complexity will be addition of length of both the strings. Again we are iterating on map also, but that is nothing but corresponding to the length of S only. So it will be actually twice of S, but this 2 is not counted. It is constant, so it can be removed. So the overall time complexity will be O of S plus T. Now talking about the space complexity, what we are doing? We are adding the characters of S as well as we are adding the characters of T inside two maps. So again the space complexity will be O of S plus O of T, where S is the length of string S and let me just write down length of string S, and T is length of string T. So time complexity and space complexity both are O of S plus T in this case. So hope you understood this question. Thank you.